So today for our experiment, we'll be looking into the 10th one, okay, which is nothing but the shift registers. I think all of you have studied in your theory classes, the shift registers. Can you tell me what's a register? You can unmute and respond.
A collection of counters.
Counters, are you sure it's counters?
A collection of flip-flops,
Correct,
not counters.
correct. So a register is a collection of flip-flops. Why do you think we have to go with registers? What's the importance of using a register?
It can store many bits at a time.
Correct. So with flip-flop, it is not possible because it's only one bit storage. So what we do is we employ a register, okay, which is a collection of flip-flops. Okay. So here in our registers, okay, we have seen the right shift, left shift operations, okay, and accordingly we have even seen these configurations in our theory, right, which is serial in, parallel out, parallel in, serial out, parallel in, serial out, and shift right and shift left. Okay, so for that we will be using a standard shift register IC, which is 7495. So various pins are given here, okay, and there are different modes of operation. So based on the mode, it will either shift left, um, and it will take the serial data or parallel data, right? So let us get into the details. You have something called DS. So the first pin is called DS. So this is your serial input data. Okay. So if you want to give here bit by bit, then you can enable DS. Now D3, D2, D1, and D0. Okay. All these are actually your serial input data. Okay. From here to here is your serial, is your data bits. Sorry. Okay, and your DS is used for serial input. Okay, and not only that, it will be right shifted. It will be right shifted. Okay, next M. We have something called M. M is called mode control. Okay, when we give one, then the parallel loading of data happens, and clock 2 is enabled. Okay, so this clock 2 will actually shift right. Okay, and when I enable this clock 1, it will shift left. So based on the mode. So when M is equal to 1, then clock 2 is enabled, which means shift right operation happens. When M is equal to 0, then clock 1 is enabled and shift left happens. Okay. So as you can see here, clock 2 is for loading parallel input data and for shift left. Okay. So clock 2 is for loading parallel input data for shift left of data. Clock 1 is for right shift. Okay. So if you want to shift the data, then clock 2. Then if you want to right shift the data, then clock 1. Okay. Right. Then we have Q0, Q1, Q2, Q3. So these are the output pins. Okay. Output pins. So input pins are D0 to D3. Serial data input is DS. Mode is for loading the parallel data. Okay. And this is for enabling clock 1 or clock 2. Okay. I think this point is clear, all of you.
Yes, sir.
Okay. Ground pin is connected to 7 and 14th pin is connected to VCC. Okay. So all these numbers that you see here are the pin numbers. Okay. Now for the shift right operation. Okay. So we use this for serial input and parallel output. Okay. So in short, it is also called as SIPO. PO, okay, which is serial in, parallel out. So what is the serial in, parallel out? So data bit should go bit by bit. Okay, the input should go bit by bit. But when I obtain the output, everything should be coming together. So that is called parallel. So which means, do I have to enable my DS here because it is serial in? Should DS be enabled or not?
Yes, sir.
Yes, because it's a serial input, right? So once this is enabled, then I will give the data bit by bit. Right? So the mode control now is made 0. Okay. So when I make 0, then clock 1, which is at pin 9, is connected to a pulsar monoshot. So here what is happening? The serial input is getting converted to parallel output. Okay. So which means I have to make my DS pin 1. So after clock 4 clock pulses, the serial input data appears in the form of parallel, which will be across Q3, Q2, Q1, and Q0. So how is it done? So let us see this. So I will enable my clock 1. Okay. So your clock 1 is actually pin number 9. So left shift happens. Okay. So yeah, let me just check. Right shift. Sorry, right shift happens. Okay. So uh, clock 1, yes, the right shift of data. So which means input is sent one bit towards the right. So in order to enable this, okay, in order to enable clock 1, then M is made 0. Okay, mode is made 0. So that is what is told here. Mode is made 0, clock 1 is enabled, and right shift happens. So I will give my DS the input here, which is 1 at the initial clock cycle, T0. So at T0 time, I will give 1. So this 1 will come and sit in Q3. Okay. Then again in the next clock cycle, I will give 0. So by then what is going to happen? This 1 will be shifted towards the right. Okay. So it will be shifted here. In the next clock cycle, I'll be giving 1. So this 1 will come here. Okay. And this 0 and 1 is shifted one step towards the right. Okay. Then in the next clock cycle, I give 1. So that's the 1 here. Okay. And this 1 is shifted one bit towards the right. Are you all understanding, students, what's happening?
Yes, sir.
Okay, fine. So what is happening here? Left shift or right shift?
Right shift.
Yes, right shift is happening. So with this, we try to understand that, uh, you know, your bit, whenever you give a bit towards your input, that is across your DS, so it starts shifting bit by bit towards the right, and ultimately after about 4 clock cycles, okay, you will be able to get your final data. Is that clear, all of you?
Yes, sir.
Okay, fine. So with this, we actually say that there is serial input of data, and after 4 clock parallel output. So SIPO. Okay, SIPO. So this
Sir,
one,
it is not visible, sir. Yes, sir.
now it's fine.
Yes, sir.
Okay, so I call it as SIPO, right? Okay. So at the end, as you can see here, okay, 1 1 0 1 1 1 0 1. So this data is actually here. Okay, so you can just imagine that, this has come here. Fine. So this is how it moves. So this is happening because of the mode control and the shifting operation. Okay, so we will see the next one now, which is serial input and serial output. Okay, so what I should do here is I should be getting the output only at Q naught. Okay, so only at Q naught I will be sending the data serial input, and I should be getting the output only at Q naught. So how will I do that? The same shifting operation happens. Okay, so we will see how it works. So here the mode control is made low, which means it is the same as 0. Okay, so due to which what happens, clock 1 is enabled. Okay, so the serial input is to be converted to serial output, so which means I have to enable my DS pin. Okay, serial data pin. So after 4 clock pulses, what is going to happen? You will have the parallel output. So which means at T3 you will actually have all the bits here. Okay, at T3. But then to convert it to serial, then you need to still shift. You need to still shift. Okay. So once you shift um, the data, then this value comes here. This value goes out. This value also comes out. This value also comes out. Okay. So which means I am giving the data using serial data input DS, and I am taking the output at Q naught. Okay. So how is this happening? So we will see step by step. So I will be giving my data 1 at, as my input towards my DS. So at T naught, at that instant of time, 1 as usual comes here. Okay. Then 0 comes here. This one is shifted towards the right because mode is 0, clock 1 is enabled, right shift is happening. So at this point of time, okay, this one comes here and I have got my data. Now I am not taking data across Q3 and Q0. I am not taking data like this, but instead what I am doing, I am taking data only across Q0. Okay, so if I give it only across Q0, then after third clock cycle, what is going to happen? The one is going to come here. Which one is this? This is the one which was initially given here. Okay, as you can imagine, the previously that I had annotated 1, 0, 1, 1, right? So at this point, okay, at T3 point, what is happening? At T3, this 1 is available at Q0. So I will take the value of Q0, right? So after that, in the next clock cycle, since it is shifted, okay, this 0 will come here. I will take 0. So what is happening here? Am I taking the values in parallel or am I taking the values in serial? Yes, students? So at this point, I'm getting,
Serial, sir.
yes, correct. At this point, I'm getting only 1. Then in the next clock cycle at T4, 0. Then in the next clock cycle at T5, I'll have 1. Next at T6, I will get 1. So which means I am getting bit by bit values of my output. Okay, so this is nothing but your serial in, serial out. Okay, fine. So now we have to switch our modes and we have to go with parallel now. So now if I have to use parallel, then all this while we were using mode M as 0. Now we have to make it mode high. And not only that, we have to load the values to D0 to D3 together. Okay. So all this while for serial input, we were using only the first pin, okay, which is only DS. Only this pin we were using. We were not using these three, these four, right? And we were also using the output pin. So if it is parallel, then we were using all together. If it is serial, then we were using only Q naught. Understanding, right?
Yes,
Any
sir.
doubts? Okay, fine. So now what we are going to do, we are going to have the parallel mode. Okay, parallel mode. So which means M, all this while is to be 0. Now I'm going to make it as high. Okay. So in parallel input and parallel output, what is going to happen? Mode is going to be high and the parallel inputs are loaded to bits 0, 1, 2, 3 and clock 2 is enabled. Previously clock 1 is to be enabled. Now clock 2 is enabled. Okay. So what is going to happen when clock 2 is enabled? Immediately all the values will be available at the output. Okay. So this is enabling, okay, if you can see here, okay, clock 2 is actually for loading parallel input data and shift left of data. So that is the importance of clock 2. So parallel input is enabled and shift left of data happens. Okay, right. So so now D3, D2, D1, D0 are all having parallel inputs and all this will appear on Q3, Q2, Q1, Q0 because it is parallel input and clock 2 is enabled. So once you have this clock 2 enabled, all these data will be available across your outputs, output pin 3, 2, 1, 0. Okay, fine. Now we will see the next one, which is your parallel input and serial output. So for serial output, as usual, what we will do, okay, since it's parallel input, mode is made 1, then the parallel inputs will be loaded to uh, D0, D1, D2, D3. Clock 2 pin is pulsed once, which means just you press it, okay, clock 2 pin, and all the values, okay, whatever you have given, okay, will appear at 3, 2, 1, 0, which means across the output. Then what I will do is I will enable clock 1. Okay. And then mode 1 is changed to mode 0. Why is this? Because I want to shift, right? I want to shift right. So because of this, what is going to happen? All the data will be shifted one by one and I will be taking the output across Q0. See, whenever I want serial output, okay, serial output, then I will be changing the mode to 0 and I will be using clock 1. Whenever I want to use parallel, then mode will be made high and clock 2 is used. Did you understand, students, all of you?
Yes, sir.
Okay, right. So as soon as you have the data here, okay, you press clock 2, all the data will appear here. Then you press clock 1, bit by bit, it shifts. Okay. So at this point of time at T naught, what is happening? At T naught, what is my output at Q naught? Can you tell me which bit I'm going to get at T naught?
1.
Correct. So I'm going to get this. Then at T1, I'm going to get 0. Then it will be shifted and I'll be getting 1. Then again it will be shifted. Then this last one will come. So which means I am having parallel input, serial output. So PISO is done. Right. Okay. So now we will see shift left operation, how it happens. Now we use clock 2 for shift left operation, right? So which means we will be using, since I have my uh, shift left operation, okay, I will be using the serial input, which is D0. Okay, so D0 is here. I'll be giving input only at D0. Okay, so only at D0 serial input will be given because I'm doing the left shift. Okay, right. So in this mode, what I'm going to do, I am going to short Q0 and D1 input. So Q0 and D1 will be shorted. Q0 and D1 input, then Q1 and D2 input, Q2 and D3 inputs will be uh, shorted. Okay, so and in this mode, I'm going to make M high and serial in data is given through D0. So why is this that I am actually shorting this? So that I shift the bits one after the other. Okay, so which means as soon as I give my D0, okay, that will be connected to Q0. Okay, yeah, and then that will be shifted left. So when it's shifted left, this value comes here. Then again, this one comes here. Then again, when it's shifted left, this value, which is at D0, will appear at Q0. Okay. So here it is the reverse process. Whatever we see for shift right, so shift left happens in a reverse process. So one by one, okay, the bits appear and it is shifted towards the left. Then again, this bit appears, shifted towards the left. Again, this bit appears, it is shifted towards the left. Okay. So in this way, I will be able to shift my bits one after the other towards my left side. Any doubts, students?
No, sir.
Okay. So only thing that you have to remember is which mode is used for what. Okay. And how I'm enabling parallel input, how I'm giving serial output, and how I'm getting parallel output. So if you know that, then it's going to be very easy for you to analyze things. Okay. So any doubts, students?
No, sir.
No, sir.
Sorry, any
No,
any
sir.
Sir.
okay, fine then. So we will now get back to Google Classroom. Okay, I'll be posting also, and you can refer to it and meanwhile complete your write-up. Okay.
Yes, sir.
Sir, this is 10th experiment, no, sir.
Yes, yes.
So ninth one you didn't do, sir.
Ninth one we will do later because that is about your.
Okay, okay,
I will
okay,
show
sir.
you. First, you have to understand the shifting operation. After you understand that shifting operation, then you will be able to do these counters. Okay.
Yes, sir.
Yeah. Yeah. So these counters and all this mod counter and all will be you will be able to understand after understanding this shift registers. That's why I shifted to experiment number 10. Later we will do 9. Understood?
Yes, sir.
Okay then.